Yasus, Kalimera, good morning, actually afternoon already. Like she said, my name is Álvaro Sánchez, and I'm going to talk to you about how's the developer experience in modern Java framework. Little bit of introduction. I'm coming from Madrid, from Spain, as you can tell from my accent, it's like British. I've been always a Java developer. And nowadays I'm working at Oracle, working on Micronaut. I am of the committers of the framework. There are several things that I contribute to Micronaut, mostly build toolings and a few other things. The part of the organization where I work at Oracle is Oracle Labs, which is a research and development division, where, for example, GraalVM also belongs to. And like I said, I'm not a developer advocate or DevRel or anything like that, just a regular committer, but I enjoy going to conferences and talking about these kind of things. At a personal level, I have 2 kids, 4 and 6, so you can imagine I'm having a lot of fun. Not so much free time. And I'm also a runner. You probably are like surprised looking at me, but trust me, I'm a runner. I run a lot. I run containers, applications, and I run them very fast, very fast. You'll see that later. So I'll promise you 2 things. Let's see if I can stand by my promise. You will learn something new, and you will have fun. So let's see how it goes. Slides are available on a speaker deck if you want to grab them. One thing I mentioned, sorry, that's my Twitter handle if you want to reach out after the conference. This is the slides. So meanwhile, you take a picture of this. Come and have a seat, come closer. There will be a live demo. So I guess everybody's a Java developer here. Raise your hand. Yes, mostly, okay. Who's using Spring Boot? Yes, okay. And who's using Quarkus? Okay, all of you guys can leave the room. Thank you. No, it's a joke, it's a joke. No, who's using Micronaut? Nobody's, well, I'm using Micronaut, so I guess that's why you're here, because you want to use it. I'll tell you a little story behind Micronaut. We started in 2017 working on it, but at the beginning the name wasn't called, the original code name was Particle. Particle, the domain name was already taken. You know, we had to choose a new name. So we ran a poll internally in the team to choose a new name. And I proposed one idea which wasn't taken. I don't get why, but I think it was brilliant. So my idea was to name the framework Summer, because summer is better than spring. You're having fun, you see? Now, spring is amazing, but I'm here to talk to you about Micronaut. So there's 3 things I would like you to get from this presentation about Micronaut. Oops. One is that this modern Java framework, and by modern I mean that it wasn't designed in year 2000, like your favorite Java framework. You put the name. So it's not like it's been like 20, 23 years ago being designed when you were creating, I don't know, Word files, deploying to Tomcat or WebLogic or whatever. So the world has changed. So when we started to think about the type of applications that were created in that moment. So REST APIs, serverless functions, microservices, that kind of things. The second idea is that you can use it for all application types. So it's a general purpose framework. People typically use it for creating like REST APIs. but you can create command line applications. You can create headless Kafka consumers or producers with no REST API whatsoever, or even a serverless function, you name it. So it's a general purpose framework. And the third idea, it is highly optimized. Performance for us is really important. We get crazy to shave every millisecond from the startup time and to shave every megabyte from the runtime memory consumption. And how do we do this? We use a technique called ahead-of-time compilation. So we leverage a facility existing in Java since forever called Annotation Processing API, or APT, Annotation Processing Tool, sorry. APT allows us to essentially generate all the framework infrastructure at compile time. So for example, when you have dependency injection, which is like the core of these Java frameworks, if you think about, for example, Spring or Jakarta IE or all those like runtime-based frameworks, the amount of things they do to basically execute this dependency injection is a bit overwhelming, I would say. Because at runtime, they will scan your class path looking for annotations, and then they will visit every single jar file, every single class, every single member of the class. They will, for example, when they find like at AutoWired or at service, at component, etc., they will on the fly generate with a bytecode library. They will generate on the fly a proxy for that class that will implement it. They will use reflection for certain things, like, for example, if you have a private attribute, they will use reflection to actually be able to set the value for that. That kind of things will happen at runtime with those frameworks. But with Micronaut, all that happens at compile time. So at compile time, we are able to produce all the framework infrastructure. So at runtime, there's no reflection, there's no proxy generation, there's no dynamic class loading, and no class path scanning. And the implications of this is that it is insanely faster. You will see that in the demo. And it's faster because reflection is slow. It's true that it's becoming faster and faster in every Java release. So kudos to the Java team at Oracle. But this is still slow, right? And because it's slow, frameworks will have its reflective caches. Because you're not going to query over and over again using reflection the same information about a class, so you will cache that. But then you will find that each of the frameworks will have its own cache, reflective cache. Like, for example, Spring will have one, but also Hibernate. And this will imply more memory consumption. So we avoid all of that. And yeah, so we basically, during compilation, we visit your source code and produce bytecode. And the reason we produce bytecode is because we support Java, Kotlin, Groovy. So it's not as simple as generating sources during compilation. But actually, in the next version of Micronaut, we will create an API, like an internal API to generate sources. So possibly Micronaut 5, like the next major version, will have the compiler APIs written to generate sources. But at the moment, we generate bytecode. Generating bytecode also saves one round of compilation, because if you generate sources during compilation, then those sources will have to be compiled as well. Nothing is for free. So this is generally the idea of the framework. It's a general purpose framework, like all the major technologies are supported, and we're currently at version 4. That's the major version we're working on. I have more slides, but I'm going to skip them because I want to do the demo. This is what you came here for. So, so I have a project here. This is the size. Hope it's okay. So I'm going to do, I'm going to open a terminal, and I'm going to split right. And then on the left, I'm going to run the application in development mode. So we have a Maven and Gradle build plugins to, for example, run in development. And we can see this is like an empty application. I made a couple of changes in the POM file just to help with the demo, but source-wise, there's nothing, right? So like this is the main application class. And you can see startup time for a blank application is 344 milliseconds. So that's great. But it's an empty application, so this is not very impressive. So let's do something. On the second terminal, I will watch, like this is going to be a curl over this URL, hello Greece, which at the moment is giving a 404. But let's write something. 26 minutes. Okay, let's write a controller. This is going to be Java class, and this is going to be controller. And then I can specify the path. I have GitHub Copilot running in IntelliJ, so it will, most of the times, give me the correct answer, but sometimes it's useless. Let's see. And then, yeah, like this is like, because I've done this a few times before and it's already giving me the solution. Shut up, Copilot. So the first thing I'm going to do is I'm going to create like a simple endpoint. So this is going to be public string, say hello, okay, like this. And then this is going to get on name. If I save, you see we have detected a change on the source file, so we're compiling the application and running it again, and we have our endpoint returning the correct data. This is hot restart, not hot reload. And it's hot restart because hot reloading is terribly complicated. It's a kind of worms. There are a million things that can happen. Especially with class loaders and third-party libraries. So we didn't want to open that kind of worms. And because the startup time is so fast, we didn't bother with that and just simply restart the application and you're done. You can see that it's so fast that you almost don't notice. There are more things that will like make you appealing for the developer experience. And I'm sure you have used these path variables before in Spring or other frameworks. Raise your hand if you have used path variables. Yeah. One thing that you don't have there and you have it in Micronaut is, for example, compile time compilation or compile time check of the matching of the roots or actually the path variables. What happened here is that I introduced deliberately a typo so that the path variable doesn't match the argument. And we compile time check that. Right? You see that? The application doesn't compile. You get a compilation time error, not a runtime error. Right? So this is much better and faster feedback. Let's do some iterations over this. I'm going to create a private final string message, and then I'm going to use constructor injection. And then this is going to be like message formatted name. Okay? And then I'm going to be using add value here. And the first thing I'm going to use is like a literal value. Short value is an annotation to provide configuration at compile time. Sorry, because what's going on here? Yeah, sorry. They should make it. So we're back in business. And then this is obviously not very useful, so I will say like use the configuration key. So in this case, I'm going to be using hello message and then default value, right? So what's before the colon is the configuration key, and what's after the colon is the default value if no configuration key is created, which is the case. And we still get the message. Another thing that I want to show you is like the implicit validation. So for example, I can add here like add size. This is on the path parameter or the path variable, right? So I can use, no, not this one. Size, and then this is like 10 letters. Right, so validation fails on the request. One thing about Micronaut validation is that it's built in. Batteries included is like a drop-in replacement for most of the Beam validation API, but it's not fully compliant with Beam validation API because Beam validation API is highly coupled to reflection, which we're not going to be supporting. So for most of the things, you can use Micronaut validation implicitly, but if you want like the full Beam validation API support, you can just add the Hibernate validator dependency, and you're done with it. Okay. Okay. Another thing I wanted to show you is the the configuration files. So in here, we're going to be creating like this is hello message, and we're going to be adding here like Yasu. I don't know how to you spell this in English alphabet, not in Greek alphabet. Let's put it like this. And then we should have this changed, right? But obviously this is not very impressive or very applicable, so let's create a type-safe configuration class. This is going to be a record, so this is going to be hello configuration. And I'm going to be adding like configuration properties and then the key, like the prefix. And this will have a string message. I can add constraints here, like not blank. And I will make this class context bin instead of singleton, which is the default. In Micronaut, bins are lazy initialized by default, so they are not created unless they are going to be used. Unless I specify context, so context bin are eagerly initialized. And I'm doing this to eagerly trigger configuration validation. So if my configuration is invalid, I don't want the application to start. And then I'll do more things. I'm going to be creating a hello service. And this is going to be an interface. And this is going to have like a public string, say hello, okay? And then, yeah, public not needed in an interface. And then like a default hello service, which will implement this guy here. And let's implement the methods. And for this, we want to dependency inject the configuration. Thank you, Copilot. So we need this, constructor injection, and then the implementation, it's simply configuration message, formatted, name, blah, blah, blah. And now let's change the controller. And I'm not going to be using any of this, but instead I will use this service, private final string, hello service. No, not a string, sorry. Hello service, service, and then construction injection. Who's using field injection here? That's good, because I was about to say to leave the room. Field injection is evil. And then the implementation is simply like service say hello. No. Service say hello, name. There you go. Yes, I made a mistake. Let's see what it was. No Venus, of course, yes. This is nothing to Micronaut unless I specify the singleton annotation, right? We're back. Then next thing I'm gonna do, because like real developers, like 10x developers don't test with curl. So we'll write a test. Let's write a test so that you can see how it's like writing a test. Before doing that, I'm gonna introduce a contract for the REST API. So I'm gonna be calling this hello API. This is going to be an interface, and this guy will have here like this. And then my controller implements hello API, and then I can move the annotations to the parent. Okay, and you will say, why are you doing this? There's a reason why. So when you create an application, you get like a sample test, which does nothing like a test that the application is running. I will create my own test class. So this is going to be hello controller test. And this is going to be a Micronaut test. Micronaut test is an annotation that will do two things for you. It will run the application on a random port automatically, and then will make this test class a Vim itself. So you can inject any Vim from your application and make calls to the methods. So you surely have heard about the pyramid of tests, where you're supposed to be writing like lots of unit tests, and then fewer integration tests, and then very few functional tests. And this is biased. This approach is biased by frameworks that will take seconds to start up, right? So I challenge you to reconsider that approach in a framework like Micronaut. So let's see how it actually feels, that experience. So I have like the class, so let's write a test. This is going to be void test say hello. And then I'm going to inject one client. Like this. This is the low-level Micronaut client, HTTP client. And it should be OK. Let's see how it looks like to run this. It's because it's not hello, I think, or hi. It's Yasu, but what you can see is 200 milliseconds. 200 milliseconds to run the whole thing, the whole application. And you will say, it's an empty application. You will see a non-empty application later. One thing I would like to mention. In a framework like Spring, the number of classes, the number of bins, the number of source files that you have will have an impact, a proportional impact on the startup time and the memory consumption. And it's almost linear. The more bins you have, the more memory it will consume proportionally, more or less. Whereas at Micronaut, it doesn't work like that. There is always like a footprint, like a minimum startup time and memory consumption that you will get. And this will, like for example, if you add Micronaut data and then you have to initialize a database, that will take time, of course, not Micronaut time, but database time. But then it doesn't really matter whether you have 1 or 50 entities. It doesn't really matter. It will not take more for Micronaut to start up. What I'm trying to say is that this number, these 200 milliseconds, is not going to be like 10 seconds in a real-world application. No near that. But again, this low-level client is a bit like a conversion because it is low-level. I mean, in this case, it's marshalling the result as a string. If I had a POJO as the response, you wouldn't have to deal with JSON, so it's not that low-level. It has Micronaut serialization, which is a replacement of Jackson that you can use. But still, I would prefer to use something higher level. And for that, I'm going to be introducing a different client. So this is going to be an interface. Thank you, Copilot. And this is going to be a client annotation. This one here. No. Yes. And then I'm going to be changing this and doing dependency injection in the test arguments. So in this case, I want an instance of the hello client. Hello client, where are you? Hello client, client. And then I can simply say client, say hello, Thessaloniki. And this should work the same. So you have a contract between the client and the server. But is a Java contract. There's nothing stronger than a Java contract. So if you change the signature of the method, you'll have to make your client and your server will not compile, right? And we have the same interface for both the Java client and server. And I think this is great. This is a great idea that I recommend you to use. But imagine this demo service we have here that says hello is like a We know that we can use like the real bin, but imagine for this use case, I don't want to use the real bin for whatever reason, because maybe it's an expensive operation and I don't want to test it as part of this test. So of course, if I had like a demo service test, it would be okay to test the bin itself, but I don't want to test the bin here. There are many things, many ways to do like bin replacement. You can use mocks. You can combine mocks, like for example, if you're using Mockito, you can use a Mockito mock to replace a Micronaut bin, and the rest of the application is still like a real application, but you can like replace particular bins. So all the bins at Micronaut are replaceable, or most of them. Definitely your bins are going to be replaceable. There are some infrastructure bins at Micronaut, like internal bins, that you're not allowed to replace. But most of them are replaceable. So what I'm going to say is that I want to define like a hello service like this, and this is going to be a bin which replaces hello service. And in this case, well, let's make the test fail first and then fix it. So it's fail because the assertion is failing. What you get, it's using my bin. It's as simple as that. It's really simple. But then you will say, okay, but maybe the configuration values will come from production, will come from Kubernetes, will come from, I don't know. I don't want to rely on application properties for my test. You can, of course, have an application test.properties, but I'll show you something simpler, which is add property. So you can simply say add property, and if I say hi, this should say hi. Yeah. Right, because this is just my replacement. I know what. Yeah. Maybe I was drunk. So 3 minutes left. Real quick, let's see a different project. I have a different project here, which is, it has like an entity class, and then I'm using the same approach, like an API and a controller. This is mapping like football teams. I have a DTO. Another nice feature of Micronaut is bin mapping. This is a compile time replacement of things like a map struct. Well, it's not a replacement of map struct because you can do a million things with map struct, but bin mapping in Micronaut is aimed to help you with those typical conversions between an entity to a DTO, forth and back. And then this application is using Micronaut Data JDBC. Micronaut Data JDBC is a lightweight version of the data access solution in Micronaut, similar to Spring Data JDBC. So there's no schema generation, nothing like that. So I have all those things here, and then I have a test. Now, for this test, because this is a database application, it could be, like, for example, running with H2, the test, and it will work. But I don't want to do that. I want to use like a real Postgres container, for example, in this case, right? You can use test containers. So who's using test containers? Yes, it's really handy for these purposes. You can use test containers. And then you add the add test containers annotation, and then you create the Postgres container in your test, and blah, blah, blah. But with Micronaut, you don't have to do any of that. If we go to the terminal, and run test, ambient test. I don't know if you can see, but this is running a Postgres container. And we have, that's the real response of the server. So I'm proving you that we are having like a fully functional test that is creating a schema, inserting some data, and then it's all happening in what, in 2.6 seconds, right? Now, this is like automatic integration with test containers, which is called the Micronaut Test Resources. So Micronaut Test Resources will automatically start a test container for development and test. So if I do mn run as well, it will do the same thing. It will start a Postgres container. You can see here 2 seconds startup time, so not that bad. And this is including creating a connection pool with Hikari. So most of the time it's not about Micronaut itself, but about all the things that you have in your application. So also for, if you're going to be like regularly developing your tests, it is uncomfortable to, like, when you run the test, to have to start the container, and because then the containers will be stopped after the tests. So if you're in a cycle of quickly developing tests, one thing you can do is to start the test resources service in standalone mode, and then leave it running, and then you can go here during the test, and then you can run them. And this is using couple of annotations that are in Micronaut to execute SQL scripts or to clean them up after the test is done. And you can see when the container is running and all the database stuff is done, this is what the whole testing takes, is 200 milliseconds. This is really fast. It's really fast. I told you I run fast. And one thing to finish up, I'm over the time, but I'm sure you will like me to show the last thing I want to show, which is packaging. So if we go back to the other project, actually we'll go back to here, to this one here. Or perhaps I will use the terminal. Is it too dark? No, let's use this. In Micronaut, when you say package, by the way, everything I'm saying about Maven happens or works more or less the same in Gradle. So when you say package, by default, you get a jar file, a fat jar, a runnable jar. This is what you would expect. But if I say, give me a native image, it's a Maven package, but give me a native image. And then this is GraalVM creating a native image. Who knows what GraalVM is? Who's using GraalVM? Yeah, very good. So GraalVM is an OpenJDK distribution that will generate a native executable of your application. I have it running here, so this is let me do it again, because if you blink, you miss it. And I'm not kidding. Blinking is 300 milliseconds. And this takes 16 milliseconds, which is impressive. I can specify as well other things, like, for example, I want a Docker image, and then we have a predefined Docker files for you that you can customize. But for getting started, you will get a Docker image which is runnable, and will have your application running, the JVM version of your application, and you can ask for a Docker native packaging, in which case you will get a Docker image that has a native executable inside. And again, there's nothing, no configuration, no extra configuration for you to get this. It's all configurable, but its battery is included, like I said. And so well over time, so we'll skip right to this slide here. So this QR code is like a small survey form for me, which I will appreciate if you, it's like a 1 to 5 rating. So I will appreciate that. And I don't know if we have any question. Do we have time for questions?
Of course we do. Any questions?
So what do you do different to minimize the compilation and build time that is not affected by the number of classes that you have?
So compilation time will be affected by the number of classes. But trust me, you will not notice the compilation time. So in a real project, obviously with Micronaut, compilation times are like larger than in other frameworks because we do more things at compilation time. But this time is unnoticeable, believe me.
Because you mentioned it throughout the presentation, and I was like, what's the secret sauce behind it?
What is the
secret sauce behind it?
The secret sauce is a annotation processing tool. That's the way it works. It's a standard facility in Java. It's just that nobody cared about that. Nobody cared about applications taking seconds to start, right? And we wanted to think differently and try another way.
Thank you.
Great. We have another question here.
Hi, thanks for the presentation. I missed it. What persistence layer do you use in Micronaut? Can you use Hibernate?
You can use Hibernate. So there's two flavors, Micronaut Data JDBC and Micronaut Data JPA. So with Micronaut Data JPA, you have Hibernate. You have all the Hibernate power and all the Hibernate overhead, right?
Okay.
So it's up to you which one to choose.
Okay, and you showed us before that in 2 seconds you have a Docker container with Postgres up and running in the test?
Yes.
Or,
okay. It's, I understand it's so fast that people sometimes don't notice that, but it was starting and stopping a Postgres container before and after the test for you. And you could see I didn't write anything about test containers whatsoever. I can explain later offline how this works.
Hello. Okay, since we already have two, let's say, mature frameworks, Quarkus and Spring Boot, but now there is also a new player, the Helidon.
Yes.
Yeah. So this is also blessed by Oracle, if I'm not mistaken. So why does Micronaut has any advantage compared to this new player, Helidon?
Yeah, well, first of all, Helidon isn't new. None of the fours are new, to be honest. So I think Helidon is even older than Micronaut. Helidon is more inclined towards microprofile. And microprofile is a very opinionated set of specifications. They call them like standards, microprofile, I doubt it, but that's a different story. But for example, in microprofile you have, for example, JAX-RS for controllers and CDI for dependencies, etc. And some of those specs we are not able to support because they rely on reflection heavily, like for example CDI. So CDI is not. There's no way for us to support it in a decent way. There is a new CDI Lite project, but for example, one other thing that you can do, we do support JAX-RS. So I show you like the add controller and add get, but if you want to use add resource from JAX-RS, you can use them. And there's no penalty whatsoever because what we do is at compilation time, we will map from those annotations to the internal Micronaut ones, so you don't notice. They are only source level annotations. This is so impressive that you can even use Spring MVC annotations in a Micronaut application, and it will work the same. It's like magic, but it does work. Because we were able to read those annotations at compile time and map them to the internal annotations.
Sorry, you talked about Hibernate GBC. Do you have support for R2DBC drivers?
R2DBC, yes, correct, we do, yes. That's also put in Micronaut Data. Micronaut Data is like the data access solution, and again, it's compile time based. So, for example, the queries are computed at compile time. It is really fast, really fast. Believe me.
Awesome. So you can get Álvaro and all of the rest of the speakers outside during lunch break and throughout the day. So also make sure you network between yourselves and grab somebody that you don't know. And make sure to check out the booths outside. Enjoy the rest of your day. Thank you.
Thank you.